is cross-origin resource sharing? CORS is an HTTP header-based mechanism that allows a server to indicate any origins, blah blah blah. Since the formal definition can be confusing, let's clarify it with a more straightforward explanation. Cross-origin resource sharing is a mechanism for integrating application. CORS defined a way for client web application that allowed it in one domain to interact with the resources in a different domain. It's very important. CORS come into play under two conditions. First, when the browser is executing JavaScript code, and second, when the request is made across different domains. CORS is useful because complex applications often reference third-party APIs and resources in their client-side code. For example, your application may use browser to request a token from an authorization server, get user data, etc. In standard internet communication, your browser sends an HTTP request to the application server, receives data as an HTTP response, and displays it. In browser terminology, the current browser URL is called the current origin, and the third-party URL is cross-origin. Understanding this brings us to the concept of the same origin policy, which is crucial for understanding how CORS works. Nowadays, browsers enforce that clients can only send requests to a resource with the same origin as the client's URL. It's very important to know that cross-origin resource sharing is regulated by the browser, not the source code of your application. This means the browser enforces security policies that restrict how resources on a web page can be requested from another domain. For example, the original header, which indicates the origin of the request, is automatically set by the browser. So, the protocol, port, and hostname of the client URL should all match the server it requests. It's the same origin because only the path differs. The second example is different origin because it has different protocol. Port is also important. If we have the different port, it will be the different origin. And it's kind of obvious, but it's important to notice that different hosts will be different origin as well. You need CORS when you want to pull data from external APIs that are public or authorized. You also need CORS if you want to allow a third party access your own server resources. Let's proceed and discover how does cross-origin resource sharing works. When you make a cross-origin request, this is a request-response process. Firstly, the browser adds an origin header to the request with information about the current origin's protocol, host, and port. Next, the server checks the current origin header and responds with the requested data and an access control allow origin header. And then the browser sees the access control request header and shares the return data with the client application. Or, alternatively, if the server doesn't want to allow cross-origin access, it responds with an error message. For example, consider a site running at clientapi.com. These sites want to access resources, for example, fetch the token from a server API hosted at serverapi.com. Developers at serverapi.com first configure the cross-origin sharing headers on their server by adding client API to the allowed origin list. They do this by adding the below header to the resource server configuration. Access control allow origin. Once CORS access is configured, clientapi.com can request resource from serverapi.com. And for every request, serverapi.com will respond with access control allow credential true. The browser then knows the communication is authorized and permits cross-origin access. I think now the time to practice with Ory Hydra. Point to start our investigation is reading of official documentation. What we can read here. CORS setting can be configured via a configuration file for admin and public endpoint. We can enable allowed origins, allowed method, and allowed headers. And there is something interesting that we can write here, that the configuration that we are discussing now, it's general configuration on the server side, but some info endpoint, for example, token endpoint, user info endpoint, can be configured as client setting during client creation. There is a field allowed CORS origins that can be configured. Let's check how it's works. I'm running up Hydra via my Docker Compose file. I have explained this Docker Compose file, how Hydra and Kratos working together in separate video. I will provide the link to the video and the link to the repo. And my client application, its application are written in Vite and React. Very simple application just to test our features. Let's start with creating client in Hydra. It will be a public client, nothing special. The client is creating. My Vite application is running. Let's start the process of getting token. It's Kratos IDP. One of the advantages of my hybrid Kratos setting that you can create your own user on the flight via API. I will create the user. Change the password for the first time. Trying to log in. Token fetch failed. Failed to fetch token. Let's see our console. To analyze this error, let's do it again. CORS error. We can't get token now. We can see that it's not possible. And we can see as well that when the browser trying to fetch token, the origin header is set up. So let's try to change it. I have created client in Ory Hydra, but without allowed CORS origins field. Let's patch my client. My client ID is test client CORS. And I add these values to allowed CORS origin. Send it and let's look. Yeah, allowed CORS origins was added to the client. Let's try to get token again. Accept the consent page. Yeah, the token is fetched. Let's try to get user data. Fetch to get user data. And what we can see here. It's CORS error as well. Goes to the Hydra client setting and change configuration file a little. Let's change or add our origins to the list and run our Docker file again. Okay, Hydra is running. And let's try get user data. Strange, failed to get user data. What's wrong? No. Let's check the port. My port is error in the port 3 instead of 0. Sorry. And run our services again. Get user data. Yeah, and user data is fetched as well. So we can conclude that some configuration of CORS, it's client configuration, for example, for token endpoint. But you can also configure the general server setting via configuration file. And I would like to show you the last thing. It's about Preflight request. Let's clear our history and try to get user data again. And we can see that there is two requests, plain request and Preflight request. What is Preflight request? Yeah, it will be discovered in the next section, but what we can see here is that in Preflight request there is origin header as well. The method is options, and we can see two headers: access control request headers, authorization, access control request method, get. Let's discover what does it mean. The browser creates Preflight requests if they are needed. It's a request with option method like the following one. For us, access control request headers is interesting. The browser asks and asks, is authorization header is allowed? The same for access control request method. Is get method is allowed? The browser sends the Preflight request before the actual request message. The server must respond to the Preflight request with information about the cross-origin request the server is willing to accept. The server response header must include the following: access control allow method, access control allowed headers, access control allowed origins. In our case, we can see that server responds that authorization header is allowed, get method is allowed, our origin is allowed. After receiving a successful response to the Preflight request, the browser proceeds to make the actual request, in this case a GET request to the server. And the server will respond with requested data or content. But the important question is, which request require a Preflight request? In HTTP, request method are the data operations the clients want the server to perform. Common HTTP methods include GET, POST, PUT, and DELETE. In a regular cross-origin resource sharing interaction, the browser sends the request and access control headers at the same time. These are usually GET data requests. These requests are considered as a low risk. However, some HTTP requests are considered complex and require server confirmation before the actual request is sent. Cross-origin requests are complex if they use any of the following. Method other than GET, POST, or HEAD. Headers other than accept language, accept, or content language. Content-type headers other than multiparm form data, application X3W form URL encoded, or text plain. So, for example, requests to delete or modify existing data, or requests with authorization header are considered as complex and require Preflight reflect before the actual request. Let's conclude the main point. CORS is relevant specifically for browser-based applications, which enforce cross-origin rules to protect users. It's important to note that this restriction not apply to backend for front-end services or server-to-server communication, where different security mechanisms are typically employed. CORS is crucial for applications that need to interact with resources across different domains. It ensures that the web application can security request and receive data from APIs hosted on other domains. CORS allowed server to specify who can access the resources, which method can be used, and which headers are acceptable. The controlled access is fundamental in ensuring that only permitted requests are allowed, protecting the server from potential security risks. For non-simple HTTP requests, using methods other than GET, POST, or custom headers, CORS requires a Preflight request. This step ensures that the server consents to handle the request before the actual data transfer occurs, adding an extra layer of security. Thanks for watching and happy coding! If you have some questions regarding CORS, please don't hesitate to ask me.